In this video, we're going to look at the basic concepts of wave motion in physics. We're going to look at definition of a wave, the parameter used in wave, basic formulas in wave, and properties of wave. Okay, so let's begin with definition. Now, a wave is simply a disturbance that travels through a medium and transfers energy from one point to another without causing any permanent displacement of the medium itself. Alright, so in physics, we have basically two types of wave motion. We have the electromagnetic waves, we have the mechanical waves. Okay, now let's begin with electromagnetic waves. Now, electromagnetic waves are those waves that don't require a material medium for their production or propagation. A couple of examples: we have radio waves, we have light waves, we have infrared waves, that's heat. All right, we have X rays, we have gamma rays, we also have ultraviolet rays from the sun. Okay, so these are common examples of electromagnetic waves. Okay, so having done this, let's look at the idea behind mechanical waves. Let's wipe some parts of this, or let's wipe this page. Mechanical waves. Okay, now mechanical waves, these are types of waves that require a material medium for their propagation or production. And we have two types of it. We have the transverse wave and we have the longitudinal wave. Okay, now transverse wave is a kind of mechanical wave in which the oscillation of wave is perpendicular to the direction of wave motion, whereas longitudinal wave is a kind of mechanical wave in which the oscillation of wave is parallel to the direction of wave motion. Alright, examples of transverse wave have water wave. Okay, also note that all electromagnetic waves we looked at earlier are classified as transverse waves, which include radio wave, light wave, S waves, ultraviolet waves, the rest of them. Okay, whereas an example of a longitudinal wave, we have a typical example to be sound wave. Okay, sound wave. We also have wave on a string. Alright, it's an example of a longitudinal wave. Okay, now diagrammatically, let me differentiate between transverse and longitudinal wave. Let me show you how it appears diagrammatically. Let me represent a wave motion. Okay, so this is an example of a transverse wave. Alright, whereas a longitudinal wave, we have a shape like this. Let me see. Alright, so this is an example of a longitudinal wave. Now if you observe, you can see that here we have a compression, whereas here we have an expansion known as refraction. Okay, refraction. This is F. Alright, now the peak of a wave or the top of a wave is known as a crest, whereas the bottom is known as the trough. Alright, this is H. Okay, whereas the distance between the peak and the midpoint, this distance between the peak and the midpoint here, alright, is known as the amplitude A. Okay, so this is basically the difference between transverse wave and longitudinal wave under mechanical wave. Okay, so let's wipe this now and look at parameters used in wave motion in physics. Let's wipe this. Okay, so let's begin with frequency. Now, frequency is the number of oscillation or cycle completed in 1 second by a particle. Alright, so in wave motion, just like in simple harmonic motion, frequency is the reverse or inverse of period time. That frequency is the inverse of time. This can be used to calculate frequency, or this formula can also apply. Frequency can be calculated using W over 2 pi, where W is the angular frequency. Alright, now frequency is measured in hertz. Short form is this. Okay, now the next parameter we have is, let's talk about period, which is the time. Okay, so period in wave motion is the number of time taken for a particle undergoing a wave motion. Alright, so period is measured in seconds, which is time, and period is also the inverse of frequency. The period, which is t, inverse of frequency, or can be calculated using 2 pi over W. Alright, now let's look at the next parameter. We have the amplitude. Okay, so amplitude is the maximum displacement of a particle undergoing a wave motion, and is measured in meters. Okay, now we also have wavelength. Okay, so wavelength is also measured in meters. We also have the velocity, which is the speed of a particle undergoing a wave motion, which is measured in meter per second. Okay, so these are the basic parameters. We have others already, but these are the basic ones. Now let's look at the relationship between velocity, wavelength, and frequency in wave motion. The relationship is very important because most of the calculations we do will revolve around that relationship. So let's wipe this and look at it. Okay, so the relationship between frequency and velocity. Okay, so the relationship between velocity, frequency, and wavelength is represented as velocity equals frequency times wavelength, which is our lambda. Alright, so this is the relationship between velocity, frequency, and wavelength. This is also called lambda, the wavelength. Alright, so take note of this relationship, very, very important. Having known this, let's look at the properties of wave. Okay, basically there are about 4 characteristics or properties of a wave. The first one, we have the reflection, which is the ability of a wave to turn back when it hits a barrier. We have the refraction, alright, which is this is R, which is the ability of a wave to bend when it hits a barrier. We also have the diffraction, which is the ability of a wave to spread out when it hits a barrier. We have the interference, which is the ability of a wave to superimpose. Alright, so this is basically an introduction to the concept of wave motion in physics. Let's call it a class here. We didn't do any calculation in this video. In my subsequent video on this, we're going to focus on calculations. Hope you learned something interesting from this video. If you are new to the channel, ensure you hit the subscribe button now to subscribe to the channel for more videos like this. So like, share, and comment on this video. Tell me how you feel for what you have learned from this class. If you seem to have any specific question to ask, feel free to leave your question in the comment section below, and I'll be sure to give you a response. Alright, that's it for this class, guys. Thanks for watching. See you in my subsequent video.